Hello class, how are you doing? This is a continuation of a conic section. In last video, we talked about one of the cross section was a parabola. We used a line and a points not on that line, and we called the points the focal point. We called the line directrix to create that parabola, and we created the equation. In this one, I'm going to draw me a circle. And I'm going to pick a point inside that circle anywhere other than the center. And also I'm going to place a point on my circle. Therefore, today I'm going to call my circle the directrix. And here, if you remember, we call this one a focal point, if that was a line on the parabola. Maybe this one is also a focal point too. I'm going to do exactly what I did on the parabola. I'm going to connect these 2 points, and I'm going to find a perpendicular bisector to cut it in half, 90 degree and equal pieces. Then I pick up the points on the circle and connect it to the center of the circle and see where the perpendicular bisector crosses that line segment. Therefore, I'm going to find the point of intersection, and that's the point of intersection. I'm going to do the same thing for every point on the circle. I do the same thing here, connected, perpendicular bisector, connected. Same thing for every point. Instead of doing these processes infinitely many times, I trace H, and pretty much they give me the same thing. Therefore, I'm going to trace that one right here, and I'm going to move, and I'm going to say, what is the graph? Oh, the graph become an ellipse. Therefore, ellipse has 2 focal points. One is the center of a circle. One is a point not on the center. And the center of an ellipse is between these two. Therefore, these are called foci, plural for focal point. Then I'm going to ask the computer to ask me a favor. From a point on an ellipse, ask a line segment to the both foci and find out how much are their length. Therefore, I go to I and a J, and I measure the length, and I'm going to say this one is 265, and this one is 235. Oh, 235 and 265 is 1, 2, and oh, that's exactly 5. What a beautiful number. Then I'm going to say what happened if I move that point. What is the distance? 5. How about here? 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 5. Oh, ellipse, this is nothing except an ellipse, which the circle is a directrix, and the point which is inside the circle and not the center, and the center both are called foci. And from today, you have to know this distance plus that distance is 5. And in no matter where the point of ellipse is, that is stay 5s. Therefore, you better say the sum of these two distances is always the same. In parabola, we say the distance from a point on a parabola to the focal point have same distance to a directrix. But in here is the sum of the two distances. What do you mean by that? Means if you have a table at point A and your wife is sitting at point B on the table, and if you talk on the phone and whisper and you talking to your girlfriend, the sounds hit the wall of the ellipse and it deflected to ear of your wife. Be very careful, please. Be very careful. Therefore, on ellipse, you transfer a signal from a point to a point. On ellipse, on the parabola, we got it from space, infinitely many points to a point. but here is a point to a point. But when I move that C right here, at some point, these distance overlap each other. See? See that 395 and 105 is 5? But from point D to B, you double. Therefore, this one is double, 105 plus 105. Oh, if I take one of these and put it right here, then nowhere would be double. See, I take one of them and put them on the missing part in the bottom. And from today, you should know this distance to this distance, which is called the major axis of, what they call it major, because you have two axes go through the center. This is the small one, this is the big one. It's like a circle, you squeeze it. One side get longer, the other side get smaller. The larger one, we call it major axis. And the length of major axis is, please pay attention, the length of a major axis is the sum of these two distances. Whatever the sum of these two distances are, is the sum of those major axes. And if I move this point and trace it, that distance is the same, and the length of major axis from here to here is always a fixed number. And what is that fixed number? The distance from a point to this focal point and distance from that point to this focal point. Therefore, the sum of these two distances is always fixed and is equal to a major axis. Then by knowing this, right now, let's put them on the paper and pencil and see if we can create a formula for an ellipse. And here, this is what I'm gonna do. I'm gonna rotate my video and I'm gonna show you that paper, and I'm gonna say, what happened if I take this one as an x-axis and take this one as a y-axis and put one focal point here, one focal point here, call this one F1, call this one F2. This is the center 0, 0. This is the length of the major axis. These are the two. And I know this is my minor axis, but I have to pick a point that distance plus that, let me put it right here. That distance plus that distance should be the length of major axis. Therefore, this distance is here and this distance is here. Therefore, that is my major axis. Therefore, I'm going to call this one point A and point A, and that's a negative A. And I'm going to connect these together, and that gives me equation of ellipse. Therefore, ellipse have 7 points. 4 points on the major axis. They call this one vertex, vertex, center, focal point, focal point. And on the minor axis, you have 3 points, vertex, center, and a vertex. Let's call this length of the half of the major axis A. The other half is A, but because you go to the left, I put a negative A. Let's call this distance a B, but the x is 0 because I started from the origin, and this is 0 minus B. The distance from the center to the focal point, I'm going to call it C, and that is also a C, but the distance from a center to both foci must be the same. Therefore, that F2 is negative C and 0. And if you pick a point anywhere on the ellipse, like this point, that distance plus that distance should be that distance. And that distance is nothing except 2A, because this is A, that becomes 2A. Then tell me, what is that distance? I know the coordinate of this one could be X and Y. X and Y could be any points here. And F1 is here. And F2 is here. Therefore, that distance is X2 minus X1 squared. That's X minus C plus Y2 minus Y1, which is a 0. That distance plus that distance. And what is that distance? X minus a negative c squared plus y minus a 0 squared. That should become equal to the length of the major axis. Well, this is nothing except x plus c squared plus y squared equal to, this one is x minus c squared, that's a plus sign, plus y squared equal to 2a. How did we solve the equation containing radicals in college algebra? You isolate them one at a time. Therefore, I'm going to keep this one to the left because when I square it, at least I want to get rid of one of them. And I take the other one to the left. I square both sides. At least I get rid of one of the radical. What is this? This is gone. X plus c squared is x squared plus 2cx plus c squared plus y squared. This one is square the first term, double this product, 1 for outside, 1 for inside. 2 times 2 is 4, positive times negative is negative, 4a times the whole radical. Unfortunately, the radical did not go away, and square the last. The last one, the negative square become positive, and when I square the radical goes away. But what is inside here? X squared minus 2cx plus c squared plus y squared. Do you see what happened to the y and a y? What happened to the c and a c? What happened to x and an x? Then everything doesn't have radical. We move it to other side. I have 2cx in here. I have negative 2cx in here. I put the negative 2cx here, become positive. Right now you have 4cx. I bring the 4a squared to other side, and I have that radical all by itself on the right side. Right now I can square both sides again. And when I square both sides again, I'm going to square this side and square that side. Square that. 16 c squared x squared. That's positive times negative is negative. 4 times 4 is 16. Double it. 32 cx a squared plus square the last, 16a to the power of 4. Square that one. Multiply, double it. Square the last. Square that one, please. 16a squared. But when you square that one, the radical goes away. But what is inside? X squared minus 2cx plus c squared plus y squared. If I multiply these, that becomes 16a squared x squared minus 32c a squared x plus 16a squared c squared plus 16a squared y squared. Oh God. Let me see what I have in here. In here I have 16c squared x squared. In here I have 16a squared c squared. I bring it to other side. And remember, all of them have a coefficient of 16, 32, 16, 16, 32, 16, and 16. I can divide it by 16 and make this one a 1, make this one a 2, make this one a 1, make this one a 1, make this one a 2, make this one a 1, and that's 16a squared y squared, that's become a 1. If I bring this a squared x squared to the other side, I'm going to have x squared c squared minus a squared, because see, that become a negative. Therefore, I took care of these two. C a x squared, oh, that's right there. See, oh, this and this gone. In here, I have a squared y squared here. And I don't have a y squared. Therefore, I bring negative, and let me make sure this one is a positive. Yes, I bring negative. The 16 is gone. It became 1. A squared y squared. And in here I have 16a to the power of 4. This is gone, this is gone. This one is 16a squared c squared. And I want to know where did I use, no, I didn't use that one. Therefore, these two are constant. Therefore, this is become plus 16a to the power of 4, and the 16 became a 1, and that 16 became a 1 is a squared c squared. And if I factor a squared here, I see a squared minus c squared. Okay, tell me what I have. I have x squared times c squared minus a squared minus a squared y squared equal to, and I'm going to move this one to other side, it become a negative. Then when I multiply by negative, this become negative a squared, this become plus c squared. Therefore, that become a squared times c squared minus a squared. I just did it to make it look like this. Good job. Okay. Let me see what else I need to do. I'm going to go to that graph. Would you tell me this plus this is 2a? Therefore, that distance is a. That distance is right there. And distance is b. And that distance we call it c. There is a relationship between half of the major axis, half of the minor axis, and the distance from a center to one of the focal points. That relationship is done by that right triangle. And remember, in here your hypotenuse is a. Therefore, your a squared is equal to b squared plus c squared. I want you to look at what I have right here. C squared minus a squared. Therefore, if I bring this one to other side, the b become a negative. Therefore, that become negative b squared equal to c squared minus a squared. Wherever I see c squared minus a squared, I put negative b squared. I put negative b squared. Negative b squared. Negative b squared. I have negative b squared x squared plus a squared. That become nothing except, no, this one I don't have anything. That's a negative b squared. That become minus negative b squared x squared minus a squared y squared equal to negative a squared b squared. I divided both sides by negative a squared b squared. Therefore, when I divided it by negative a squared b squared, negative a squared b squared, negative a squared b squared, oh, that's gone. Negative over negative is a positive. That x squared over a squared. And what was that a? Half of the length of a major axis. Negative over negative is a plus. Y squared over a b squared equal to 1. This is equation of an ellipse, which a squared is a plus minus a is the length of the major axis. Therefore, if you take the square root of that one, it becomes plus minus a. And if you take the square root of that one, it becomes plus minus b. And where do you see that a? A is under x. Therefore, wherever the largest number is, major axis is going to be parallel to that axis. Therefore, if I write x squared over 16 plus y squared over 4 equal to 1, the largest one is 16. This is telling me this is 16. A is plus minus 4. The smallest one is your b squared. B is plus minus 2. Because x doesn't have plus minus h, doesn't have plus minus k, the center is 0, 0. Your a is 4. your negative a is a negative 4, your b is 2 and a negative 2, that's your ellipse. Ellipse have 7 points, 4 vertices, a center, and 2 focal points. But somebody said, what is the focal point? I said the relationship between the foci, the distance between the center to the foci, and the distance from a center to the vertex, which give you the minor axis, and the distance from the center to the vertex, which provides you with the major axis, which is that distance right here, because this plus this is 2a. This relationship, which is b squared, you always have to remember b c a. This is not a Pythagorean theorem. Unlike Pythagorean theorem, here the hypotenuse a squared, and that's b squared plus c squared. Therefore, on any equation of the ellipse, if you know your a squared and b squared, you should know the c. Therefore, this is your b, this is your c, this is your a squared is 16, your b squared is 4, I don't know the c squared is 12, and c is plus minus 2 radical 3. Therefore, this distance is 2 radical 3 over 0, and this is negative 2 radical 3 over 0. But somebody said, what happened if my ellipse become elongated along the y-axis? You just switch your a and a b. Wherever your a squared is major axis along that one. If I put y here, then the elongation is going to be along the y, and the short one is along the x. Or sometimes a student leave the x in here, leave the y here, and move the a and a b. It doesn't matter because the addition are commutative. Somebody said addition. Why did you put plus? Why you didn't put negative? Because I said the sum of two distances is fixed. That's the sum of two distances. Somebody said, what happened if the center become at the center at h and a k? Therefore, you get x minus h squared over a squared plus y minus k squared over b squared equal to 1. This is for an ellipse that elongation is along the x and the minor axis is along the what? The y. But this one, if I switch them and put y minus k squared over a squared, elongation is along the y and the minor axis is along the x. Therefore, this is another conic sections. You should know this one from a pre-calculus, but I hope you enjoyed that one. Have a great day. Next time, we're going to talk about hyperbola. Thank you.